One of the most important concepts for saving computation and improving latency in software is caching. Imagine opening a food delivery app and requesting the most popular restaurants near you. To produce that answer, the server may need to find nearby restaurants, check which ones are open, calculate their distance, count their recent orders, and rank the results. That can require significant computation, calling multiple microservices and querying several data stores. Now imagine hundreds of users in the same area making an equivalent request. Repeating all that work for every request would be slow, expensive, and wasteful. This is where a cache can help. A cache is a fast, temporary storage layer. It keeps copies of data or the results of expensive calculations that are likely to be requested again. Instead of rebuilding the restaurant list every time, the server can calculate it once and store the finished result in the cache. When another equivalent request arrives, the server checks the cache first. If the result is available, it can be returned immediately without repeating the service calls, database queries, or calculation. This is called a cache hit. If the result is not available, we have a cache miss. The server must then call the required microservices, query the underlying data stores, and calculate the answer normally. Before returning that answer, it also stores a copy in the cache. The next equivalent request can then reuse it. But caching introduces another problem. Cache data can become stale. For example, a restaurant may close while the cache continues returning an older response that says it is open. That is why cached entries are usually assigned a TTL, or time to live. The TTL defines how long an entry can remain in the cache before it expires. Once it expires, the next request calculates a fresh answer and replaces the old result. And that's really all caching is. Do the expensive work once, keep the answer nearby, and reuse it while it's still valid.